Hello everyone. So today we are going to solve a problem on Norton's theorem. Norton's theorem. So any complicated circuit can be simplified into a simple circuit which has current and load resistance both in parallel. So this is the circuit given to us, and he's asking us to find out the current in 4 ohms. So this is the question given, and this is 2 ohms, this is 3 ohms given, and this is 6 ohms, and this is 24 volts given. So he is asking us to find out the current in 4 ohms using Norton's theorem. So step 1 in Norton's theorem will be short circuit RL is equals to 4 ohms, comma, name it as A and B, comma, redraw the circuit. A and B and redraw the circuit. So let us quickly short circuit. So redraw the circuit. That would give us A and B, right? So this is 2 ohms, this is 3 ohms, and this is 6 ohms, this is 24 volts. So the next step would be finding total current. Step 2 will be finding total current. Step 2, total current. Just give me. So total current I is equal to, the formula is V by R equivalent. Now if you observe, the current is coming from this source. So current will come like this. From here it would go here and it would go like this. So I can say these two resistances, 2 and 3, are in parallel. So when resistances are in parallel, what you do? R1 R2 by R1 plus R2. So 2 into 3 by 2 plus 3 plus what is the resistance left out? It is 6 ohm. So 6 ohm will be in series. So this will give us R equivalent. Now once you get R equivalent, what do you do? 2 into 3, 6 by 5 plus 6. So this will give you the value. So whatever you are getting this value, substitute in the place of this. I is equal to, what is V given? 24, I guess. So R equivalent, whatever you are getting, you write it. So that is amperes. So this is the first step. Second step. Now what is the third step? What is the third step? Step number 3. To find Norton's current. To find Norton's current. What is the formula? IN is equals to total current in the circuit. Just now you got, no, in the second step, I into, this is important, I into, what is the resistance you have to take? What is the resistance opposite to short circuit? 3. 3 by 3 plus 2. You should take 3 by 3 plus 2. Why you are taking 3? Because it is the opposite to short circuit. So you will get the value of Norton's current, IN. Okay, so this is over. Now next step 4 is to find Norton's resistance. To find Norton's resistance. So how will you find Norton's resistance? What is the formula? So it is Rn. So if you have voltage, so at this point is common to Thevenin and Norton. So at this point, what you have to do? If you have voltage source, short circuit. I have voltage source not 24 volts. So short circuit, 24 voltage source, comma, redraw the circuit. Redraw the circuit. So if you short circuiting means I'll remove that component. So get you get it like this. Short circuited and so this is your A and this is your B. So here in this case I have to open it here. Why I am opening it here? Because see, if I close it completely, no, from where I'll find Rn. So this is your Rn. Now what you have this side? If you see the question, you have 2 over here, 6 over here, and 3 here. Now the flow of current, our assumption would be it is flowing from this side, right? So now I can say 6 and 3 are parallel. So when resistances are parallel, R1 R2 by R1 plus R2 plus 2. So that would give us 18 by 9 plus 2. So that is 2 plus 2 equal to 4 ohms. So I think it is, what is it giving here? So last step would be drawing Norton's equivalent circuit. Norton's equivalent circuit. So what is the equivalent circuit of Norton's theorem? It is simple. So you just draw IN, okay, and RN, okay, and RL all together in parallel. So this is your Norton's current, this is your RN, Norton's resistance, and this is your load resistance RL given in the question. I guess it's given as 4 ohms. So wherever he is asking you to find out the current, that is your RL. Now the last step would be finding the current in 4 ohms. Current is denoted by I and you have to find the current in 4 ohms. So what is the formula? IN IL is equals to IN into RN by RN plus RL. You know how you got Norton's current, you know RN, you know RL. So that's all. Thank you.